Good morning to all of you. My name is Dr. Veena Bharti and I am Assistant Professor at AKGEC Ghaziabad. Today we are going to discuss about the topic Hadoop. That is included in the big data and that is the 6th semester subject. So the topics here are Hadoop. First is history of Hadoop. Then why Hadoop is used. What is Hadoop? Advantages and disadvantages of Hadoop. How Hadoop works, components of Hadoop, Hadoop data format, then big data lifecycle, benefits of analyzing big data. Okay, so Hadoop. In this slide, there is a 2002 and 2003. In 2002 and 2003, Dow Cutting and Mike Kerfere started working on Nudge. So in 2003, Google publishes GFS related paper, that is the research paper, and Dow Cutting uses that research paper, and Dow Cutting adds DFS and MapReduce support to Nudge in 2004. Then in 2006, Yahoo hires cutting Hadoop spins out of Nudge. So in 2007, he has learned that New York Times convert 4 TB of data of image archive in over 100 EC2. Then in 2008, Facebook launches Hive concept, the concept of Hive. SQL support Hadoop and Facebook also uses the concept of Hadoop. Then in 2008, Yahoo also used that one, and the fastest sort of a terabyte, that is the terabyte data is sorted in 3.5 minutes over 910 nodes. Then in 2009, there is a concept of fastest sort of a terabyte, that is 62 seconds over 1460 nodes, sorted a petabyte in 16.25 hour over 3.658 nodes. So basically the Hadoop concept is come into existence in 2006. History of Hadoop. Here Apache is the company which has overtaken the concept of Hadoop, and so Hadoop Apache Software Foundation is the developer of Hadoop, and its co-founder are Dow Cutting and Mike Kerfere. Its co-founder Dow Cutting name its Hadoop because of his son's toy elephant. And in October 2003, the first paper release was GFS. In 2006, MapReduce development started on Apache Nudge, which considered of around 6,000 line coding for it and around 5,000 lines coding for HDFS. And in April 2006, Hadoop was released. So basically, if you are talking about Hadoop, then it came into existence in April 2006. That is the first version of Hadoop was released in April 2006. That is the 0.1.0 version. Then DFS. Here we have used the concept of DFS. So what is DFS? DFS is basically distributed file system. Distributed file system, that means the file system which is distributed across multiple machines, and the purpose of this distributed file system is to promote the sharing of dispersed file. This is also an active research area today, and clients should view a DFS the same way they should view a centralized FS. That means the centralized file system is same as distributed file system for a client, and the distribution is hidden at the lower level. Then DFS provide high throughput data access and fault tolerance because it is in a distributed environment. So that is why its throughput is high, and also it is fault tolerance. Then concept of Hadoop, why Hadoop is introduced. So basically Hadoop infrastructure provide these capability. First one is scalability. That means we can scale it up to thousands of computed nodes, and a petabyte of data can be handled through the Hadoop. Then also cost effective because it is run on low cost commodity hardware, so that is why it is cheaper. So that is the reason it then Hadoop is used. Then third is the efficiency, because the data is in distributed manner, so Hadoop can process it in on the parallel node where the data is located. So that's why it is more efficient. Then Hadoop as a solution, because the challenges in centralized file system are, first one is single central storage, because there is a single central storage, so it is very difficult to overcome if there is any fault occur. And the solution that is given by the Hadoop is the distributed storage. Then second is serial processing. In centralized file system, there is a serial processing because all the data are stored at a central level, that means at a single server. But in Hadoop, the data is distributed environment, so that is why parallel processing is allowed. Third challenge is lack of ability to process unstructured data, because RDBMS and other concepts are used to handle that data, and it is not able to handle the unstructured data. So that is why Hadoop is used, because it has the ability to handle both structured and unstructured data, that is every type of data. Then Hadoop is in use at most organizations that handle big data. The examples are Yahoo, Facebook, Amazon, Netflix, etc. These are the examples that basically uses Hadoop to handle their big data. Some example of scaling are scaling concept. Yahoo search web map runs on 10,000 crore Linux cluster and power Yahoo web search. Also Facebook Hadoop cluster hosts 100 plus petabyte of data and growing at half petabyte per day. That is, the size is very huge. That is why Hadoop is used. Hadoop in the wild, the basic use of Hadoop is here. System requirement here is high write throughput, cheap elastic storage, low latency and high consistency, and also disk efficient sequential and random read performance. Then Facebook solution, Hadoop plus HBase act as a foundation for Facebook because it has a huge amount of data. So Hadoop plus HBase is used. Then it improves and adapt HDFS and HBase to scale a Facebook workload and operational consideration. So here major concern was availability. That means name node, because here the basic rule is name node is single point of failure. If name node fail, then it can't be recovered. So there is a concept of secondary name node, and fail over times at least 20 minutes. Then second is proprietary avatar node. This eliminate the SPOF and makes the HDFS safe to deploy even 24/7 uptime requirement. And third one is performance improvement for real-time workload. So here RPC timeout, rather fail fast and try a different data node. So these are the basic solution which is used by Hadoop. So that is why Hadoop came into existence. Then what is Hadoop? So Hadoop is a open source software platform. First is it is open source software. That means it can be easily changed and it can be easily downloaded, and it is a software platform for scalable. Scalable, that means it can be easily extended and in a distributed computing. Second, Hadoop provide fast and reliable analysis of both structured and unstructured data. That means it can easily handle both or different types of data that may come into existence, or you say in big data, variety of data can came, so it can be handled easily by Hadoop. So here Apache Hadoop software library is also essentially a framework that allows for distributed processing of large data set across cluster of computing using a single programming models, because it provide huge amount of library and it is in distributed environment, that is cluster of computing are used. So here with the use of huge library, a simple programming model is used. Then Hadoop can scale up from single server to thousands of machines, each offering local computation and storage. Hadoop. Hadoop is distributed with some part is centralization, and main nodes of cluster are where most of computational power and storage of system lies. So here main nodes of clusters are where most of computational power or system lies. Then third is main node run task tracker to accept and reply to map reduce task, and also data node to store needed blocks closely as possible. Then central node runs name node to keep track of HDFS directories, files, and job tracker to dispatch compute task to task tracker. That means if client request for any query, then it will came into for task tracker, a job tracker, then job tracker, then provide it to task tracker, and it is the responsibility of task tracker to complete that task and return it to job tracker. Then Hadoop is written in Java, and it is also supported by Python and Ruby. Hadoop distributed file system. So here concept is HDFS. HDFS is Hadoop distributed file system. So DFS we have already learned, and it is linked with Hadoop. So the concept is HDFS, and it is a distributed, scalable, and portable file system written in Java for Hadoop framework. Each node in Hadoop instance typically has a single name node and a cluster of data name node, because the data is basically stored at a data node, and the all the data nodes are replied by name node. That means the single name node can handle all the data node. So basically the data which is stored in data node can be handled by name node. So a cluster of data node from HDFS cluster. The situation is typical because each node does not require a data node to be present, and each data node serves a block of data over network using a block protocol specific to HDFS. The file system uses the TCP/IP layer for communication, and client uses the RPC to communicate between each other. Hadoop advantages and disadvantages. These are the advantages. First is the ability to store a large amount of data that we have already discussed. Second is it is fault tolerant and highly available. Why it is fault tolerant and highly available? Because the data is in distributed manner. Because the data is in distributed manner, that means if one of the node fails, then we can overcome it by another node. So that is why it is fault tolerant, and it is in distributed manner. That is why it is highly available. Okay, then third is it is compatible with all platforms. Then fourth is distributed computing, because the data is stored in a distributed manner, so it is distributed computing. And also cost effective. It is cost effective because it runs on low commodity hardware and allows parallel processing. It allows parallel processing because of distributed computing. Then disadvantage. What is the disadvantage of Hadoop? It is not very efficient for small data. Then hard cluster management, because clustering environment is there, so it is very difficult to handle the cluster management, and has stability issues and security concern. So these are the basic disadvantages of Hadoop. How Hadoop works? Hadoop work on the basis of, because Hadoop is based on DFS concept, that is distributed file system. So here the data is initially divided into uniform size block of 128 MB or 64 MB, preferably 128 MB. So first data is divided into blocks. Then these files are distributed across various clusters for processing, and the HDFS supervise the overall processing. Blocks are replicated. Because of this, the Hadoop is your fault tolerant. So blocks are replicated for handling hardware failure. If one of node fail, then it can be overcome by another node. Then next point is performing the task that takes place between map reduce and further stages. Next point is send process data to the certain computer and write the debugging logs for each job assigned. So that is how Hadoop works. Then characteristics of HDFS. HDFS has high fault tolerance because of distributed manner. Then HDFS may consist of thousands of server machine, that is cluster environment is there, and each machine store a part of file or system data. HDFS detect fault that can occur on any of machine and recover it quickly and automatically. Then HDFS has high throughput because it is in distributed manner. That means it can run parallelly on various machines. So that is why it has high throughput. Then HDFS is designed to store and scan millions of rows of data to count or add some subset of data, and the time required in this process is dependent on the complexity involved. Then it has been designed to support large data set in batch style. Okay, so here streaming is not allowed, so here batch style is used. However, the emphasis is on high throughput of data access rather than low latency. HDFS is also economical because of low commodity hardware, and HDFS is designed in such a way that it can be built on low commodity hardware and heterogeneous platform, also which is low priced and easily available. So that is why it is economical. Then components of Hadoop. Hadoop has basically three components. First is Hadoop HDFS, that is Hadoop distributed file system is the storage unit. That means ki HDFS is the storage unit that stores all the data. Then second is Hadoop MapReduce. MapReduce is basically its processing unit. That means first data is stored by HDFS, then it will send to MapReduce for processing, and Yarn is a resource management unit that can handle between HDFS and MapReduce. So basically Yarn acts as an operating system that can handle or that can act as resource management unit. And the full form of Yarn is yet another resource negotiator. HDFS terminology. So here first is here components of HDFS has Hadoop HDFS. So HDFS stores large file across multiple machine. It achieve reliability by replicating the data across multiple hosts and hence does not require RAID storage on host with the default replication value 3. That means by default it has 3 copies or 3 replication is stored, and data is stored on 3 node, 2 on same rack and 1 on a different rack. Then data node can talk to each other to rebalance data. That means the data is rebalancing by data nodes to move copies around and to keep the replication of data high. So here HDFS has many parts. First one is name node. Name node is the node that stores the metadata for the file like directory structure of typical file system, and the server holding the name node instance is quite crucial as there is only one copy. That means it has a single name node, and the transaction log for file, delete, add, etc. does not use transaction for whole block or file stream, only metadata. And also name node handle creation of more replica blocks when necessary after a data node failure. So it can handle that also. Here is the diagram of name node. Here name node. Here the message came. Here this is the name node, and name node have metadata, that is dn1, data node 1, it has a copy, then dn2, dn3, and here file system. That means metadata stores about the details of data node. And here data node 1 contain 2 blocks A and C, data node 2 contain AC, data node 3 contain AC, and in this way many data nodes are available. So here the data node sends heartbeat that it will be alive. So that is why data node sends the heartbeat to name node, and every 10th heartbeat is a block report. Okay, then it will send a block report to name node that it is correctly working, and the name node builds metadata from block report. TCP every 3 seconds. If name node is down, HDFS is down, because the name node is existing in a single point. Then second is data node. Data node, actually the data node stores the actual data in HDFS. So all the data in HDFS are stored in a data node, and it can run on any underlying file system. That means it may be ext34, NTFS, etc. And it notifies name node of what block it has. That means the data node contain many blocks, so it will send the information about data node to name node. Then name node replicate blocks 2x in local rack and 1x elsewhere. That means 2 copies of same data node or same block is stored at a single block, that is local rack, and 1 copy in another rack. So the data node stores data in Hadoop file system. A functional file system has more than 1 data node with data replicated across them. On startup, a data node connect to the name node, spinning until that service comes up. It then respond to request from the name node for file system operation. Client application can talk directly to data node once the name node has provided the location of the data node. Here, in this case, when the client sends any request, then it has to send to name node, and the name node sees about the metadata, the information that client need, and then the client is redirected to the name node. That means the client can be directly communicated through the data node. Then data replication. Why need data replication? Because HDFS is designed to handle large scale data in distributed environment. So that is why data replication is necessary, and also hardware or software failure or network partition exist. Therefore need replication for those fault tolerance. Replication factor, that means how many replicas are created, that is decided by user and can be dynamically tuned. And how to create replication efficiency? There is a replication pipeline. Instead of single machine create replication, a pipeline is applied. Pipeline works on the principle of machine 1 make replication to machine 2, at the same time machine 2 make replication to machine 3, etc. So in this way replicas are created. Then replica placement, how replicas are placed in a data node. So here high initialization time to create replication on to all machine and approximate solution. That means only 3 replication can be required. First, only replication reside in current node, second copy reside in current rack, and third copy in another rack. So that is how 3 replicas are stored in a data node. First in the current node, second in current rack, and third copy is in another rack. This is the replication pipeline diagram. Here these are the file text, block A, block B, block C, and there is a request from client, I want to write file.txt block A. So client requests to write file in block A. So it has to first send this request to name node, and here the name node check about the rack awareness. So it has read from metadata, that is rack aware, rack 1 data node 1, rack 5 contain data node 5, and rack 5 contain data node 6. So these are the 3 copies. So it has sent the message, okay, write to data node 1, 5 and 6. So here 5 nodes are there in which copies of the block A exist. So name node sends this request to client, and then client is directly attached to data node. So client has request a ready message, ready data node 5 and 6. First, this is the rack 1 and second is rack 5. So here rack 1 has data node 1 and rack 5 has data node 5 and data node 6 that contain block A and that contain block A. So client request for data node 1 and it has sent the ready message that I am ready to write the content in block A. Then it is also parallelly sent the ready message to the rack 5 that contain data node 5 and data node 6, and these sends the message that is ready data node 6, ready data node 5. So that is how the replication pipeline computes. So here name node picks 2 nodes in the same rack and 1 node in a different rack. Data protection locality for MapReduce. Then heartbeat and re-replication. Here is the diagram. So here re-replicating missing replicas. Here name node. If any one of the copies misses out or any data node fails, then these information can be sent from the data node to the name node that this data node fails. So it is the responsibility of data node to recreate that data node in another form. So here the name node sends the message, oh missing replicas. Data meta node contains the information about data node 1 that has 2 blocks AC, data node 2 contain AC, data node 3 contain AC. And here is the rack awareness. Rack 1 has DN1, DN2, rack 5, DN3 that fails. So it sends the information to metadata and metadata sends the information to name node. That is copy block ACT to name node 8. So here name node sends the data node AC, this is data node 2 AC and this one is fail. So it has created a new copy block AC to node 8. So it has created the data node AC copy to data node 8 that contains same block, that is AC, because the data node 3 fails. So that is how the re-replicating missing replica work. So here missing heartbeat signify lost nodes. That is why there is a concept of heartbeat. That means the data node sends heartbeat for in every 10 seconds about the data node is working properly or not. Then the name node consult metadata and find affected data, and name node consult rack awareness script. Then name node tells a data node to re-replicate. So that is how re-replication works. Then this is the rack awareness diagram. Here there is a concept of name node. Name node consists of the information about the metadata and a rack awareness. That means how the data are arranged in a racks. So here is a concept of switch also. Switch, this is the switch and it has a switch data node 1, data node 2, data node 3, and in that way there is a rack and each rack contains some of the data node and the data node basically contains the blocks. So in another diagram, this is switch 2 and it has rack 5. Rack 5 also has data node 5, data node 6, 7, 8, and each data node contains a block. If this is the rack that fails, so that is the information that is sent to name node for rack awareness, that which one is working properly and which one not. So in this way, never lose all data if entire rack fails. If entire rack fail, then also it is properly working. And keep bulky flows in rack when possible. Assumption that in rack is higher bandwidth, lower latency. Data node failure. Data node failure condition. If data node failed, name node could not know the block it contained. Create some replication to other alive node and unregister this dead node. Then data integrity. Corruption may occur if network transfer, hardware failure, etc. So there is a concept of apply checksum, checking on the content of files on HDFS and store the checksum in HDFS namespace. If checksum is not correct, after fetching, drop it and fetch another replication from the other machine. So thank you.